10-2-21.
But we can drop it.
Okay. If we have time. Iffy. Yeah. If we have time. Yeah, Ferris.
27.
On which section?
10.2.
27. Going once. Going memo. Really? I'm kidding. Go ahead. What is it?
Can you do production on 10.2?
Are you just making shit up now?
I'm not.
Okay.
I
Production.
think 10-1.
And
10-1.
Yeah, it's 10.1, I'm sorry. 10.1.
production. And I had another over there. What was it?
That's the one I was gonna ask for.
Okay, awesome. Haha. Okay, let's start with 10-1 and work our way up. 10.1. Production. Is this the 70T one? No, that's not. No,
2017.
2017 minus, or plus 6T squared, minus T cubed. So this is production as a function of time is 27T plus 6T squared minus T cubed. And that 0 is less than or equal to T is less than or equal to 8. Remember I told you those matter. Okay?
Oh, yeah.
So let's read the statement. A time study shows that on average, the productivity of a worker after T hours on the job can be modeled by this function, where P is the number of units produced per hour. Find the critical values, which critical value makes sense, for what values of T is P increasing, and graph the function for 0 less than or equal to T less than or equal to 8. So find critical values, that's where the slopes equal 0, right? So let's do that. What's P prime?
Negative 3T squared plus 12T plus 27.
Yeah, so she just ordered these, brought this out front, took the derivative, left this where it was, took the derivative here. So now we set it equal to 0, and I'm gonna factor out a negative 3 while I'm at it. So I get T squared minus 4T minus 9. Everyone cool with this? Well, that's ugly. Because what multiplies to 9 or negative 9 and adds to negative 4? Nothing. Nothing that we know of, right? So what can we do instead? So this is not easily factorable.
Quadratic formula.
Yeah, we can do the quadratic. How many of you like the quadratic?
You're hating.
Uh-huh. There's like none of you, literally none of you are raising your hands. Okay, so what's the other option? Autumn, what did I teach you today?
5 by T. I don't know. What I
Well,
learned
just
today.
say, if you don't like factoring, what did you do? You got on your calculator and you did what?
I'll graph it.
Graph it.
Oh, yeah.
When in doubt, guys, graph it out, okay?
Sorry.
If you can't find an easy quadratic, or if you don't like the quadratic, or if you've forgotten the quadratic, graph your derivative. Wherever it crosses the x-axis is where the slope is 0, right? Because when we're graphing the derivative, we're graphing x versus slope. So wherever we set that sucker on its function, so if we graph t squared minus 4t minus 9, we'll get some t where the slope is 0.
6, 1. Negative 1.
I'm just gonna do it because, oh wait, I already had it in there, damn it. T squared x squared minus 4x minus 9. So if I graph this, I'm graphing the derivative, guys. I get a function that looks like this. This is P prime. Okay? So I'm gonna have 2 places on the original function where the slope is 0. Am I even gonna bother looking at this one?
No,
Why not?
because the 0 to t thing.
Yeah, because t has to be between 0 and 8, so it better be between 0 and 8 over here. So far, so groovy?
And I felt like you could have negative time too.
You can't have negative time, that's another reason, yeah, that works as well. So in order to find this, you need to do second calculate zeros, and you're gonna do left bound, right bound, and then guess. You're basically making the cars crash over the X value you want. That's what you're doing. So second calculate is above trace, arrow down to 0. Left bound, you want the cursor to be a little bit to the left of that point. So I put my cursor down here because that's a little bit to the left of this X value. Hit enter, and then cursor until it's a little bit to the right, up here. Enter, and then guess, enter. And I get X equals 5.61. So this X value right here, or T in this case, is 5.61. Questions? Yeah?
You said something about sloping 0 where the function crosses the x-axis.
Yeah,
How is the slope?
this is the derivative, Caitlin.
Okay.
We're graphing X versus slope, not X versus Y. So this is all positive slopes over here, negative slopes down here, 0 slope across here.
So t is the slope.
No, the Y values in these cases are the slopes. So at X equals 5.61 or T equals 5.61, the slope of your original function is 0. Graph the original function.
Of the original function.
Yeah, this is where your slope is 0 on the original function. So we take the derivative, set it equal to 0. You can't factor it because it's fugly, so graph it instead. And wherever it crosses the x-axis is where the original slope is 0. You guys aren't buying it, are you? None of you are buying it. Yes, Blaine.
So you used
Like, I mean,
minimum
Sorry?
in the first second calc, was that a minimum?
It may not be a minimum, it may be a maximum. In fact, with production, it probably is a maximum. Because think about it, production's gonna go up over time, right? Awesome, okay. All right. So find the critical values. Well, one of them was negative, so we discard. Which critical value makes sense in this model? The positive one. For what values of T is P increasing? Well, for everything to the left of this and everything to the right of this. Right?
So would you use the negative point as well?
Yeah, no,
No.
not in the model.
So then you would say everything after equal
Everything
or
after
greater than
5.61 has a positive slope.
Okay.
Yep, and then graph the function for 0 less than T is less than or equal to 8. So you just change your X min and X max to 0 and 8. And graph the original function. That's it. You guys look so doubtful. Talk to me. All of you are giving me the oh hell no face, so talk to me.
The 0 is, sorry, less than or equal to t, and t is less than or equal to 8. That is what you would put like your max and min
Yeah.
values at.
Yeah, so I would set my window, I would make this my X min, and I would make this my X max, because I don't care about anything else, right? X is my T in this case, X is my input, so you could just substitute X in here if that's easier for you to look at. That's all that matters, just as long as you remember X is time in this application. Did you guys graph it? The original function?
Doing it.
No. 27t plus 6t squared minus t cubed. My window, I can go from 0 to 8. My x min and my y min, I can make 0 and home, who knows, I'll make it 500 for giggles. That's weird. Oh, I see why. Okay, so I was like, why is this? Here's why, guys. So my original function, this guy up here, P of t, graphs like this. So here's 0, here's 8, and I took this up to 500 just for giggles. So remember how I said that this should be negative slope and this should be positive slope out here? Well, they're switched, clearly, right? We start with positive slope and then we go negative. Why is that? What did I factor out? A -3. Your critical values won't change, but the slopes will flip because I factored out a negative number. So if I were to have graphed this instead, this would just be flipped
Okay,
over.
yeah.
Okay.
That's what I was just thinking.
Does that make
If
sense?
that was a +3, would that function be like upside down, like?
No, this won't have changed. This is P. This is my original function, P of T.
And then how do you find that T
Okay,
plus five
production
minus
is a function of time.
I know, but I'm just saying, like, it would be a different function because if you factored out a positive number.
Yeah, it would still be the original right function.
If
This
you
is just a
factor out-
factor of growth.
If you
Oh,
factor out
very
a
good.
positive number, the original function, the right side would be
Oh, okay.
going up.
You're trying to get
Right,
closer
so
to
this
line,
would be
right?
flipped. So this, no, this would not change, is what I'm trying to tell you. This would not change. The original function does not change. What I factored out of,
Okay.
what I factored a negative number out of was the derivative. So the slopes are gonna change on the derivative. So let's graph. There it is. I'm gonna graph that. And it's gonna look like this. Instead. But you're still gonna have the same T, 5.61.
Into the original function.
Nice.
And the reason is I changed the slope. I changed the look of it. I had a positive T squared down here, which is a parabola opening up. But I left the -3 in, so now it's a parabola opening down. But the same two critical values hold true. Okay, guys?
So,
Same ones. You're good, Ryan?
yeah,
I'm good, okay.
a little tired, but good.
Who else has questions on this one? You all look like thoroughly confused. I need you to be good with this before we move on. Okay, I'm gonna assume you're good with this. Moving on. 21. On 10.2. A function and its first and second derivatives are given. Use these functions to find relative maxima, relative minimum, points of inflection, and sketch the graph of each function. So we were asked, is yours the one with x to the 1/3 on it?
No, that sounds like a good one.
No. Tell me what yours is.
Mine's the 3x to the 5th minus 20x.
Okay, got it. All right. So this is 3x to the 5th minus 20x cubed. And then f prime is going to be 15x squared. They have it all factored for you, isn't that pretty? X minus 2, x plus 2. And then f double prime is going to be 60x and x squared minus 2. Isn't that nice? How do I find critical values, guys?
Is that equal to 0?
Set what equal to 0?
We're gonna set the derivative.
The derivative, yeah.
Wait, 15 times 2 is 30.
What's up?
But you said 60x, where are you doing 60x?
It's factored. If I were to FOIL all this out, Caitlin, and take the
Because you
derivative.
took 1 from each of the x plus 2's.
No, you can't treat this like a straight derivative. You don't get to do that. You would have to treat it like a product, but it's a triple product. So you would have to FOIL it out, get some number, and then take the derivative, and this is what you would get if you factored it. What it's done is it's had the original function, and then it took its derivative and factored it for you, nicely for you. And then it took the derivative and took its derivative and factored it for you, nicely for you. Okay? So you don't have to mess with this. It's set. We're good. So we're gonna set this equal to 0. f prime equals 0. So 0 equals 15x squared,
Yeah, that's the one.
x minus 2, x plus 2. So just like we set a derivative equal to 0 and then solve for x, we would have factored this, and this is the factored numbers we would get. So it's skipping to the good stuff.
Thank God they did that.
Yep, that's, I'm like, isn't that nice? They gave it to you. So now you have 3 solutions. What's the solution to this term?
That's the one.
15x squared, I'm just gonna just give it to you. 15x squared is 0. How do you solve for x?
Divide by 15.
Divide by 15.
Which is still 0.
So what's the square root of 0? 0. X equals 0. So that's one of my critical values. X minus 2 equals 0. X equals 2. There's another critical value. X plus 2 equals 0. X equals negative 2. That's a third critical value. So how do I determine what they are? We know the slopes are 0 at these 3 x values. Now are they maximum, minimum, or points of inflection?
Plug them
Plug them in where?
Second derivative.
in first.
Second.
Oh.
If we plug them into the first derivative, we get out slope of 0. Right?
No, just the f of.
Yeah,
Just the
we
function.
want the second derivative now. So I'm gonna test each of those in the second derivative. All right. So the way we do that is we just plug and check. So f prime, or f double prime of 0 equals 60 times 0 is 0, 0 minus 2. What's negative 2 times 0? 0. So x equals 0 is a horizontal point of inflection. Okay? Everyone cool with that? Okay, when we have a concavity of 0, that's an HPI or a VPI. But in this case, we know it's an HPI because why? What's the slope? Yeah, so it's either doing this or it's doing this with that point slope of 0. Okay? So now we test 2. F double prime of 2 equals, gosh, 120 times 2 squared is 4 minus 2. What's 120 times 2? That's a positive answer. So is there a minimum or a maximum built into that concavity, guys? It's a minimum. So x equals 2 is a minimum. Okay, now let's test negative 2. So that's negative 120. Negative 2 minus 2 equals negative 4 times 1. Negative 120 is what?
Trying to find why they're making it order.
Shit, is that right? No, that should be positive 4. You guys almost caught me.
So negative 240.
Yeah, so negative 240. So the answer is negative. Is that a max or a min?
Max.
That's a max. X equals negative 2. Max. Have you massively overthought these? How about just a little bit? Little overthought.
Yeah.
Okay, we use the second derivative to find concavities. Concavities can help us identify maxima, minima, and points of inflection. So far, so groovy?
Yeah.
Okay. Grab your tattoos. Oh wait, no, not quite yet. Let's look at 27. I lied.
This was my number 21. 10.2.
Is 27 the one with the graph? Yeah. Okay. Are you serious? There we go.
No.
Oh, that's way dark. Sorry. Nope. Doc cam. I can read directions. It's magic. Okay. See how far this goes. Come on. Do it. Do it. No. Okay, good. All right. Zoom in. Zoom in. Yes. Okay, can you guys see that?
Yeah.
Okay, pretty well. All right, so in problems 27 and 28, use the graph shown in the figure and identify points A through I that satisfy the given conditions. So A was f prime of x greater than 0 and f double prime of x greater than 0. G, that's like saying slope is positive and concavity is positive, right? So where is positive slope? So it's this region, right? So now we identify the points that also have positive concavity. Does this? No.
No, sorry.
How about here?
Yeah.
Yes. How about here? Careful. You're going from concave up to concave down, so that has a concavity of 0. How about here? Careful. You're going from concave down to concave up. That also has a concavity of 0. So where's the only place that satisfies slope and concavity are positive? That's it. Next. F prime is less than 0 and f double prime is less than 0. So we're saying we're looking for a negative slope and a negative concavity. So the only region of negative slope is here. So let's focus. Is that negative slope? No,
0.
but it has negative concavity. Negative slope or negative concavity?
Yes.
Negative slope, not negative concave.
How about negative slope and negative concavity?
Yes.
Because, look at this, guys. Concave down, concave up. Somewhere in here it's changing concavity. I'm betting it's at D. You guys with me? Okay, so C has negative slope, negative concavity. That's the answer. Did you guys overthink these two? Yeah, big time. That's okay though. That's what I'm here for. F prime of x is 0 and f double prime is greater than 0. So what are we looking for?
So no slope and then a positive.
0 slope and concave up. Where are the only places that satisfy that? We have 3 0 slopes, B, F, and I. Which one has positive concavity? F. You guys with me? Can you do the rest of them? Chandelier, talk to me. Okay. Where did I lose you? On B? Okay, so let's look at that one more time. F prime is less than 0 and f double prime is less than 0. So let me write that out. F prime is less than 0, f double prime is less than 0. So this is like saying negative slope, right? Because f prime is where we go to get slope. So we're looking for negative slope. And f double prime is less than 0, so that's concave down. Okay? So we're looking for places where the slope is decreasing and the concavity is negative. All right? So the only place where we have decreasing slope is here. So far so good? Because this is growing, this is growing, this is 0, this is growing. So far so groovy? Okay, so now we need to look at general areas. Is that concave up or concave down? Is that a happy face or a sad face, Chandelier? It's a happy face, so that's concave up. That's positive concavity. What about this?
Down.
That's down, that's a sad face, right? So it's gonna be up here somewhere. We need a negative concavity. So where has a negative slope and a negative concavity? B has 0 slope, negative concavity. C has negative slope, negative concavity. Here's the slope at C. It's decreasing. Does that make sense?
Yes.
At D, we're probably shifting from concave down to concave up. Do you see that it sort of inflects right here? So this has a concavity of 0, so that won't work. So this is the only place that will work. Okay?
Thank you.
Make a little bit better? I don't want you guys to feel lost. Speak up if you get stuck. That's what I'm here for.
I think that was really helpful for me at least.
Yeah, seeing it like that?
Yeah, where you go to derivative.
Yeah,
Derivative
draw the
against slope.
pictures, guys, draw the pictures. And then limit yourself using one of the two things. I said, well, let's limit ourselves using slope. Well, the only place that has negative slope is right here. So now we look at concavity at each of those given points. So far, so groovy.
Yes.
Can you do the rest of them?
Yes.
Awesome. I should have just drawn that in. But it was easier to show you the book. Yes. No. Okay. All right, you guys. Let us tackle the rest of chapter 11.1 and then dive into 11.2. So you should have your tattoo out. And again, I'm going to exhort you guys, please don't miss any more than you can help from here on out. Because you're gonna be a really sad clown if you do. Really sad. This stuff is the important stuff. This stuff is the big stuff. All right. All right, logarithms. So I already talked to you guys about the basic derivative of logarithm. 11.1 was logs. And the basic function was if f of x equals some natural log of some function, that its derivative is gonna be the derivative of the junk over the junk. That's it. So now we're gonna dive a little deeper into that, and we're gonna use those shortcuts on the right-hand side to help peel them apart into chewable bits. For example, if I give you a function that looks like this, y equals the natural log of 6x cubed minus 10x squared over 15x minus x to the 5th, and this is all to the 4th power, you wouldn't want to take that derivative, would you? Nope. But guess what? You can. We're going to start with the outermost layer. Don't look at the log now, look at this. This is a what?
Power.
Power. We have a shortcut for the natural log of some function to a power. So look on your tattoo, about halfway down on the right-hand side, 2/3 of the way. What do we do with that power? We're gonna bring it out front. So the natural log just becomes p natural log of m. So I'm gonna drop it. Damn it, I didn't mean my pen. We're gonna drop it down to reflect that. No derivatives are being performed here. I want you to keep that in mind. 6x cubed minus 10x squared divided by 15x minus x to the 5th. That's not so bad. We're getting rid of some of those layers. Is there something that can help us now in those shortcuts?
Well,
Would it be the m over
Does it
n?
remain
Yes.
to the third, like how normally?
This is not a derivative, Caitlin. Look,
Okay.
not a derivative. So all we're doing is we're rewriting the function so that we can take the derivative. It's a great question, but we're not there yet. All we're doing is we're peeling it apart so that we can take the derivative. Our goal is to make it pretty. Natural log of some easy peasy function. And And Autumn, you nailed it. It's natural log of m over n. So what can we do with those?
Subtract.
Yeah, it becomes natural log of m minus natural log of n. So I'm gonna do that. Y equals 4 natural log of the top, which was 6x cubed, minus 10x squared, minus 4 natural log of 15x minus x to the 5th. Why did I put the 4 on both of those terms?
That's what it says on the tattoo.
Because that's what it says on the tattoo. Part of it, yes, Corwin, part of it. But really the answer is this 4 tied to the entire quotient?
Yeah.
Yes.
Yes. Therefore, it will be tied to both parts of the quotient when we peel it apart. You guys with me?
Now we can take the derivative.
Now we can take the derivative. What is it? Y prime equals 4. Constant coefficients always go along for the ride, guys. So what's the derivative? Don't overthink it.
18x squared minus 20x.
Divided by?
6x cubed minus 10x.
That's the first one. Minus 4 times what? There it is. That's a really elegant derivative, isn't it? So much prettier than the quotient rule, right? So much prettier. So the lesson is, when you're confronted with a natural log function that's gory, pick it apart. Make it easier so that you can actually take the derivative nicely and tidily. Okay? Talk to me. Questions?
So you throw a junk on the bottom.
Yeah. This is just u prime over u. U prime over u. 4
So
goes
each of
along.
those were its own unit.
Mhm. Yeah, this is natural log of some stuff, so the derivative is the derivative of the stuff over the stuff. This is a natural log of some stuff, derivative of the stuff over the stuff. Blaine,
I was gonna say, what exactly happens to the natural log,
the natural log,
like the ln?
it disappears. Remember what we did before? The pattern of the natural log looks like this. So the slope of x is gonna be 1 over x. So natural log of x has a slope that's 1 over x. So the derivative has no natural log in it, right? None. But don't worry, it'll come back when we do integrals. It'll come back. Yay, just like all those constants you were killing killers.
So when you
Those
take,
come back too.
so when you take the derivative, the ln's just disappear?
Yeah. Bye-bye. Yeah, it's nice, isn't it? Okay. Wanna see another? Sure. How about this one? You guys are gonna be like, that's not what you just said. You just said the natural logs disappear.
I had to,
Mm-hmm.
he said it.
Is that
They
how we
do.
sound?
What?
Is that how we sound?
Kinda, sorta.
I pointed
You know how
to it.
sometimes when you're talking amongst yourselves and I just sound like womp, 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 womp up here?
That makes sense.
You gotta sound like this to me. How about this one? Y equals the natural log of 3x minus 4 divided by 6x squared plus 17x. That is not the same thing.
Because the parentheses are only the top?
Yeah. What's the subject of the natural log this time? Is it both the numerator and the denominator? No. Do you see the difference? This is a quotient, guys. Yeah, that didn't go away. So what's my u?
Okay.
And what's my v? Too slow. Oh, sorry. That's just too easy. So what's my U prime?
So is the ln also included in the U?
Yeah, my U is the entire numerator, right?
Yeah.
So what's the derivative of that? It's gonna be 3 over 3x minus 4, right? Well, if U is just natural log of some stuff, what's the derivative of the natural log of some stuff? It's the derivative of the stuff over the stuff. Here's the derivative of the stuff, here's the stuff. Ew. Was waiting for that. What's V prime?
12x plus 17.
And because this is a quotient, we just use the quotient rule. So Y prime, here we go, is U prime times V. Minus U.
So there's like 2 U primes, essentially?
We have nested U's. Times V prime. Whoops, yeah. Divided by, I knew you guys were gonna love this, V squared. I know I sound like I'm really enjoying your pain, but you guys can handle this. You know how I know? Because everyone that came before you handled it too. Tristan,
You can put the square in.
son of a bitch. Yeah. Son of a biscuit eater. Who else was gonna say that? Ferris? Okay, I'll give you guys both the points.
What'd you find?
She didn't have the square.
I didn't have the square on my V downtown. U prime V minus U V prime over V squared. So remember how I said the natural log would go away? Only if you're taking its derivative, guys. You're taking its derivative, it goes away. But if you're using it, it doesn't disappear, does it? It's still there. Ugh, indeed. A little math heartburn going on. Yeah. Are your quotients repeating on you?
See, I liked that you made shortcuts for the last chapter.
Right! So
Now
many
there's
shortcuts.
No shortcuts.
There's still shortcuts. There's still shortcuts, yes.
So I'm just making sure, so the function with, natural log in it is just the, yeah, okay, never mind.
You have to understand what you're looking at
Yeah.
first. Yeah. If all of this is inside the natural log, then you can use the natural log rules to peel it apart.
And so the reason why V prime is not over something is because it's just a regular, because
Yeah.
it doesn't have a natural.
It's not
log.
part of the natural log.
Okay, cool.
Yeah. Yeah, Marco.
If there's a natural log on the top and bottom, is that the same as writing it outside of?
Yeah, like a quotient. Yep, so if you have natural log of something over the natural log of something, that's like saying the natural log of something over something.
Okay.
Okay? Precisely.
So,
Dope indeed. And I just ruined it. Dope.
Like
Indeed.
if that, like if there was natural log in front of 6x squared plus 17x, it would be like how we did it over there.
Mm-hmm, exactly, it would be just like this. It would be the same thing. But since it's not a natural log quotient, or not a natural log over a natural log in a quotient, you can't treat it like that. This is not natural log related. You have to treat it like a regular function. So it's a function of some sort, fugly or not, it's a function of some sort over a function of some sort, making it a quotient. Right?
What if it was a natural log, like what if it was a product that was like that?
Sure, let's do it. Why not? Did you guys try to look over the handout that I gave you?
we tried,
Did you do the work on it?
not yet,
Well, you didn't really look it over then, did you? No.
I thought about it.
No, you thought so hard, so
I
hard.
wanted to.
It was just such an effort to lift your pen. I get it. arguments for a product. Here's my U. Here's my V. U prime. V prime. There is nothing in here you guys don't know how to do. Not a single thing. Which is why it's so important to be here. Because then you don't miss out on the skills necessary to take the next step. Because this is a very steppy class. Yeah,
Why is it not 24x squared?
because I'm wrong. What's your name again? Avery. You get the point. Thanks, Avery.
So like, in that case, you treat the V as if it was like V prime over V, like, over here.
Wait, what?
For that.
Sorry, I'm sorry, Caitlin.
Okay.
Say that again?
So like, you're using U's over here, but the log is in the V, so you
Yeah.
just do the same thing, but like.
Right, just like how we had nested functions before where we had globally it was a product, locally it was a power kind of thing. So we had a global U and V and then a local U and V or a local U. Here we have globally it's a product, locally it's a natural log. So we re-identify this. So in the subworld of V, we have natural log of some U. So that becomes U prime over U. So far, so good?
Yeah.
Okay, so now we just pull it all together. Y prime becomes U prime. Let's see if I can do this without screwing it up.
You can screw up, we'll fix it.
Yeah, I know you will. I have like complete confidence in this class. You guys are awesome. You are. You scored 10 points higher on average on the test than the other class did. So right now, you guys are my bomb diggity group.
We are pretty cool.
10x to the 5th minus 6x times v prime is 24x squared, Avery, divided by 8x cubed minus 14. And there's your derivative. There is nothing in here you don't know how to do. Dang, that's far away. Okay. We're gonna move on from here. We're gonna go into exponentials.
It's 11 too.
Yep, 11.2. It's not even groups. 2, 4, 6, 8, 3, 6, 9. Alright. So logs and exponents are tied together, guys. They are tied together around an oblique asymptote. So we already talked about what natural log looks like. It has a vertical asymptote and it crosses at x equals 1. E to the x runs along the horizontal asymptote. And it looks just like that. And it crosses at y equals 1. Okay. So no matter what x you shove in, could be negative, could be positive, can you ever get a negative y out of e to the x? You cannot. Let me demonstrate. Let's say y equals e to the negative 5. That's like saying 1 over e to the 5th, isn't it? Which is still a positive number. You guys with me? So you will never cross this horizontal asymptote and go into negative y territory. Not ever, not ever, not ever with these functions. And they're symmetric about the origin or an oblique asymptote, such that if I folded the whiteboard along that red dotted line, these would sit right on top of each other. And that's how they're related. They're really pretty. They're actually kind of awesome, and that's why we use them. It's because they're very pretty. That's why. There's no other reason. We use them because they have unique properties. But now I want to talk to you guys about exponents and how they're related to each other, how exponents are related to logs. Remember I said 10 cubed equals 1,000? And so log base 10 of 1,000 equals 3. That's how I opened up the log discussion last time. Yeah, Corwin?
Shouldn't the e be to the negative 5 in the denominator?
No,
Why not?
because I brought it downtown and changed the sign.
Oh, okay.
So remember, x to the negative 2 is like saying 1 over x squared.
Right.
Yep, same thing. Groovy? Okay. So there's the relationship between exponents and logs. So what if I said log base 10 of 10 cubed? What would the answer be? You don't need a calculator for this, just common sense. Yeah, it would be 3. So when the bases are the same, the exponent is the answer. Are you guys with me? When the bases are the same, the exponent is the answer. So let's relate this over here. Natural log is just log base e. That's all it is. It's log base e. E is a number. It's like 2.71 something or other. It goes on forever. So we just give it a name like pi. It goes on forever. So if I write something like this, natural log of e to the 5th, what's the answer going to be, guys? 5. Do it in your calculator if you don't believe me. Try it. Have a sense of curiosity. Insatiable curiosity. Anybody read like stories when they were kids?
No.
You remember the Elephant's Child? Rudyard Kipling? No? Okay.
Like how
Little
tens are
little
like,
classics for you guys. What was that, Caitlin?
the E, like, is it supposed to be like how like, it's like log 10 to, like log 10,000?
Yeah.
Is it supposed to be log like E and then X?
Natural log is log base e. So this is like saying log base e of e to the 5th. So if I rewrote this, it would look like this. Log base e of e to the 5th equals 5. Okay,
Oh, I see.
you see it?
And then they're the same.
When the bases are the same,
You got it.
the exponent is the answer. So natural log is just log base e. All right, so did you guys do natural log of e to the 5th power? You got 5 as your answer? So what do you think the rule is here? If I ask you to find the derivative of something that looks like, oh, I don't know, this, natural log of e to the 6x cubed minus 10, what does that simplify to? So what's the derivative of that?
did the E go?
Aha, where did it go?
So it's like,
We just did this.
okay.
We just got rid of the natural log of the E stuff, because when the bases are the same, the exponent is the answer.
And you know the base is the same because
Yeah.
it doesn't say it's different?
This is log base E,
Yes.
and this is base E.
Okay.
Bases are the same, so the exponent is the answer. And then we can easily take the derivative. Okay? It works both ways, guys. What if I gave you over here, y equals the natural log, oh no, sorry, that's not what I meant to do. Y equals e to the natural log of x cubed minus 6x. When the bases are the same, this is the answer. So this simplifies to x cubed minus 6x, and then its derivative is just 3x squared minus 6. And this is also on your tattoo, both of these things. So on your tattoo, exactly halfway down on the log side, you have two things that talk to you about what we just did on the board. Natural log of e to the x is just x. E to the natural log of just x is just x. You guys cool with that? So there's everything is on here. You just gotta learn how to read it and use it. Groovy? So now I'm gonna introduce you guys the derivative for 11.2. It looks a little different than the natural log. You know how the natural log disappeared when you took the derivative? Right? Sort of. Like, sort of disappeared. Yeah, the e does not. Here's what it looks like. 11.2. So this is the last derivative that we're talking about. It's the third one in the group. Exponentials. So if f of x equals any e to some power, then its derivative is the derivative of the exponent times the original function.
You didn't write that derivative over there with the e to the u,
I could have though,
but you didn't.
but I could have.
So can you just not?
What do you mean?
I mean, you didn't put like.
I didn't do that?
Yeah.
I didn't need to. Let me show you what I mean. We had e to the natural log. Is that the one? Or natural log of e to the blah, blah, blah?
The one that was over there was, it was y equals natural log e to the 6x to the third minus 10 equals 6x to the third minus 10, and then you put y prime equals 18x squared.
I'm gonna show you guys how to do that without the shortcut. Then you're gonna be grateful for the shortcut. You ready? What's the derivative of the natural log of anything? It's the derivative of the thing over the thing itself. So y prime is going to be the derivative of this thing follows this formula. 18x squared e to the 6x cubed minus 10 divided by the original thing, e to the 6x cubed minus 10. These cancel, you're left with 18x squared.
That was the long way, or that was
That's the long way. That's the long way.
There's a shortcut to that?
Yeah, that's how we did it before.
Just
Rec-
knowing that they always cancel.
Well, yeah,
That wasn't hard.
that wasn't so hard, but how many of you want to do the derivative of that? I don't really. I would much rather do the derivative of that, which is what we did over there. Okay? All right, so let's go back to exponentials. This was just an aside. I'm going to erase it, okay, guys? Okay. How about this one? Oh, no, you know what? I'm gonna introduce you guys to something else too, while we're at it. How many of you remember learning how to write when you were a kiddo? Yeah? Do you guys remember this stuff? Yeah. And then you had to follow patterns, right? And they're like, let's see, big A uses the whole thing. Little a is just this part. Big B, you get the picture. Little b. And you're like, Jesus Christ, Jessica, what are we doing now? All right. What I'm trying to tell you is I want you to go back to kindergarten, just for a little bit. And I want you to use, you'll see why. I want you to use a line for every layer. Watch me. Y equals 6 e to the 5x cubed minus 10x to the 4th. I am being extremely conscious, and I could just make this even worse and divide the 6 by 5, because why not, right? I have several different layers going on here. I have a denominator layer, I have a base layer, I have an exponent layer, and I have an exponent of the exponent. I want you to be very careful about how you write these. I see it time and again. People get cramped and they try to cram it all onto one tiny little line, and then they go blind trying to read it. Don't do that. Write big, kill a tree today. I can't believe I'm saying that out loud.
Autumn.
I know, it's horrible. What?
I like paper.
I like paper too. It's a tool. Use your tool, okay? Just use it until you get comfortable with this. So now let's look at taking the derivative. Constant coefficients go along for the ride. Let's identify our parts first. U, in the context of the exponential, is what? U is our exponent. What is our exponent? I heard chandelier started, I think.
Wait,
U is 5x cubed minus 10x, all to the power of 4. You guys with me? U is my entire exponent. Here's e to the u power. So what's your prime? Haley, is that you? Go ahead.
4 minus 5x cubed minus 15x
You guys ready? Here's your derivative. Y prime is 4 junk to the third times the derivative of the junk. That's U prime times the original function, 6 over 5 e to the stuff. And I want to show you once again how cautious, what? Oh, I'm not gonna erase anything. How cautious I'm being with layers. The denominator layer is sitting solo. That 5 down there, sit solo. Hang on, Caitlin. My base layer is this layer all the way across here. Even on a whiteboard, I'm being careful. My exponent layer is right here. My exponent of my exponent is up here on its own. So I'm being very careful. Okay, Caitlin, what's up?
I was just gonna say, the only reason you're not like, looking at it as a power and a quotient is because it doesn't have an x in the bottom.
Yeah, this is a constant coefficient. It just goes along for the
But
ride.
if it was like.
And you'd have to
5x,
treat it like a quotient.
Okay.
Yep. Or you could bring the x up and treat it like a product, where 6 times whatever is the u, and then v is this entire mess over here. So globally, here's u prime. Here's your constant coefficient. And here's e to the u. So it's still u prime e to the u. Just depends on what u and e to the u are. Doesn't it?
What is
You
that?
got it, we're just.
What, oh, I'm not erasing anything else. I was just getting rid of the stuff I didn't need. Memo, was that you? Yes, question? Blaine? I heard somebody right in this area. I'm missing a smart ass.
Oh,
Yeah, where'd he go?
He's not here today.
Well, clearly, does anyone know?
That's why it's so quiet.
I wanna check on you guys. See, you're not the trouble.
What? No, see what we feed off of each other.
Oh, is that it?
Yeah.
Well, him by
I was-
himself is still a pain.
Well, no, I just feel like a jackwagon.
Oh.
Yeah. It's a sad day.
You know what's funny?
What's that?
My dad's name is Jack, and I always use like vernacular words with Jack, and he's just like, it's your fault, it's your name. He hates that. It's hilarious. I love getting his goat. All right, let's look at a couple more. I know you guys are getting restless, but I want you to be comfortable with these. Because homework's gonna be ugly. And I wanna show you guys that they're not nearly as bad if you take them by piece, by piece, by piece. Y equals x over e to the 3x. Deceptively simple, yes? Mm-hmm. Globally, what is this? Yeah, it's a quotient. So we're gonna use u prime v minus uv prime over v squared. So what's my u? Yeah, so globally is a quotient. And my v is my denominator. So then my u prime becomes 1. Heard that over there. Was that you, Ferris? Okay. And what's my v prime? And this is what I was talking about, Caitlin, with nested u's. So now I have a u in my v. I got chocolate in my peanut butter. I know, it does. Yeah,
Then it'd be 3.
so what's my v prime?
3.
Times? Plug and chug. You ready?
Is that because
What?
your u inside the v is 3x?
Mm-hmm.
Your u inside the v is
Mhm.
the exponent?
Mm-hmm. Sure is. So then, when we get to our v, forget that it's v and just look at it. What's the derivative of that? We use this process to do it. Right, guys? So forget that it's v, just look at it as a function. What kind of function is this? It's this kind of function. So it uses this kind of derivative, right? So now we just plug it in. By prime. I know you guys hate me right now. It's okay. Is u prime times v minus u times v prime over v squared. And if I really wanted to simplify this, which I do, I would have e to the 3x minus 3x e to the 3x over e to the 3x quantity squared. What do I have in common with all three terms? Yeah, I can get rid of some e to the 3x's, make this a 1.
Are you
Get
gonna
rid
have
of
us
that.
simplify for this unit?
No? But you might want to practice trying anyway. So this becomes 1 minus 3x over e to the 3x. Isn't that prettier than that mess over there? You're like, no. Leaving it raw is prettier for me because then I don't have to work on it. I understand that feeling.
Why the two go away on John?
Aha, because I just pulled an e to the 3x out of the top, out of each term,
Yeah.
leaving a 1 here and a 3x here. And I pulled an e to the 3x out of here, leaving just 1 left over. This is like saying e to the 3x times e to the 3x. So if I get rid of one of them, I get rid of the squared, and then I just have 1 left over. Does that make sense? Yeah. Awesome. How many of you hate me right now? It's cool.
Not really.
How many of you sort of hate me right now? How many of you don't hate me but hate the math?
Oh, yeah.
You guys get extra credit. All, I'm kidding. All right,
I didn't know that was
here's your homework. Because I know you were waiting for that.
Now.
Your tattoo is gold. Do not lose this. Use it for your homework. Use it for class. Use it for everything. Groovy? Here's your homework. And I'm around this weekend, so call me. Gesundheit. Eleven point one. I'd like you to do 1 through 24 every other odd. That's like maybe 6 problems. And then I want you to do marginal cost, please. And demand not part C. If you do, I'm gonna be very sad. And then on 11.2, please do 1 through 36 every other odd. It's like 9 problems. Future value. Sales decay.